In this section, we're going to talk about marginal analysis. And this is really the big business section that we do in this course. So we're going to see cost, revenue, profit, and we're going to play around with the idea of how do we use derivatives with those types of equations. So when we talk about cost, cost is how much it takes for a company to produce something. When we talk about revenue, revenue is the amount of money that the company brings in. So define revenue. If we're not given a revenue equation, we could come up with an equation. So revenue is how many items you sell times the price that you sell them for. So sometimes you don't have the revenue equation, but you have all the pieces to create the revenue equation. So I'm going to call revenue R of X. So X is how many items that we sell, and P is the price. So sometimes you may have the price equation, how much you would sell each item for, and you would be able to figure out revenue just by multiplying that price equation by X. And then we have profit. Profit is how much money you have left after you take into account the cost. So define profit is going to be the revenue minus the cost. So those are a couple of foundational things we need to understand before we move into this idea of analysis and using calculus to analyze our types of equations. So I'm just going to talk about the cost equation, but this same concept is going to work for revenue and profit as well. So let's say we have a cost equation X, and we want to figure out what marginal cost is. Well, first off, marginal, anytime you hear that word, I want you to think about rate of change. And rate of change we can find by taking a derivative if we're looking for an instantaneous rate of change. So how is it changing when we produce the 21st item in our assembly line, or if we produce that 300th item? Maybe we're selling TVs, or we're selling some kind of gaming console. How is our cost changing as we produce some of these items? So when you hear marginal, think derivative. Okay, so we're looking for an instantaneous rate of change. So if we have a total cost, then the marginal cost is the derivative of the cost equation. The same thing is going to be true with revenue and profit. If we have a revenue equation, remember, and we can find revenue by multiplying X times the price if we're given a price equation and not the revenue equation directly, then marginal revenue is the derivative of that. To find profit, profit is revenue minus cost. Marginal profit is the derivative of the profit equation, which would be the derivative of the the derivative of the revenue minus the derivative of the cost equations. So when you hear marginal, think derivative. So really, all of this is kind of built on those premises from differentials. We said that when we were looking at differentials, that for very small slopes, very small changes in X, and we could use delta X to talk about that. For small changes in delta X, the slope of the tangent line is approximately equal to the slope of the secant line. Well, the slope of the tangent line is found by taking the derivative. The slope of the secant line we could find by looking at that difference quotient, f of x plus h minus f of x all over h. And as long as we're looking at small delta x's or small h's, we could use either one of these here. I'll use h. Actually, to stay with my notes, I'm going to use delta x. That's the change in the x value. So for very small changes in delta x, then the slope of the tangent line is equal to the slope of the secant line, which means we can use derivatives, because that's what this is, to approximate that exact change. When we're talking about selling items, the smallest amount of change we could have, that smallest delta x would be equal to 1. Because we can't sell a portion of an item, like we can't sell half an item. We either sell one item or we don't sell any. And the smallest amount we could sell would be 1. We could certainly sell more than 1. So in most of these examples, we're going to talk about what is that exact change between selling maybe the 20th item and the 21st item, and then how can we use derivatives to help us come up with that value. So, and that's what we're talking about here. So when I talk about C of x plus 1, C is the cost equation, and that's the total cost of producing x plus 1 items. C of x is the cost of producing x items. Now, if I take those two numbers and I subtract them, that's going to be the exact cost of producing the x plus first item. So maybe this is 41 and 40. That would be the cost of producing the 41st item. Now, if we're using differentials, and we know derivatives can be used to approximate the exact change in the cost in this example, then our delta x value is going to be 1. So we could use that derivative to approximate that exact change in cost for that one item. So then we can talk about average. When you hear the word average, you probably think about adding up all the numbers and then dividing by how many you have. We can use that same concept to talk about an average cost. On average, how much does it take us to produce 40 items? Well, to find the average cost, it's going to take that cost equation, and we're just going to divide that cost equation by x. X is how many items that we're selling. So notice the notation here. That bar over the top means average. If you've ever taken a stats class, when you talk about averages there, which we call the mean, you use that X bar notation for a sample. So we're using that same kind of notation that you would see in a statistics class. So you just take the cost and divide by X. Same thing is true with revenue and with profit. Now, if we want marginal average cost, so what is that instantaneous rate of change in that average cost? Marginal means derivative. So you're just going to take the derivative of that cost equation. Same thing would be true with revenue and with profit. You just take the derivative of that average revenue or that average profit. So let's look at a few examples. In this first one, we're doing a cost analysis. They're giving us a cost equation. They're asking us to find the exact cost of producing the 21st food processor, and then we're going to use marginal cost to approximate it. So this is going to let us see how close that marginal cost is to that exact cost. So first thing we need to do in part A is we need to find the cost of producing 21 food processors. So what we're going to do is we're going to plug that number into our equation. I'll write it out this first time. And if we were to type that in the calculator, I got 2829.50. And then we need the cost of producing 20 food processors. So if we plug 20 in for those X's, I got 2,800. So that exact cost for the 21st, if I take the total cost for producing 21 items and I subtract the total cost for producing 20 items, And that's going to give me that difference. And that tells me the cost of producing that 21st food processor. So you can see that's quite a process to get to what that exact cost would be. Marginal analysis will make this just a little bit easier. B is asking us to use marginal cost to approximate that. So marginal means derivative. We're going to take the derivative of the cost equation. So there's our derivative. And we want to approximate the cost of using the 21st food processor. But look back here. Notice that we're not going to plug 21 in. This would be 21 and this would be 20 in our case. We're actually going to plug in the number 20. So we would approximate that to be $30. Now look how close those values are. They're only off by 50 cents. Like we said before, this is kind of a process to get there. It wasn't that bad of a process because that equation's not that bad to deal with. But if the equation would have been more complicated, or we were doing this for quite a few different computations, it could get a little tedious. And that's where that marginal analysis comes in, because we have an easy equation to plug it into, and then we just type that number in. It would be really easy to set up like an Excel spreadsheet to be able to do that. The trick here is remembering what you're doing and what number you're plugging in. It's important to plug in the 20. It's all based around the theory up here, the fact that I could use C prime of X to approximate that exact cost. So everything's based on that theory, really from that last section on differentials. So let's look at another one. We're going to do another cost analysis here. They're giving us a cost equation. This one just happens to be linear instead of quadratic. A is asking us to find the average cost per item if we sell 500 frames. So average cost, remember we take that cost equation and we are going to divide it by X. We want to take the total cost and divide by how many items we sell. So our total cost equation is 60,000 plus 300X, divide by X. So this is going to be 60,000 over X plus 300. So if we want that average cost when we sell 500 frames, we're just going to plug 500 into here. So I've got 60,000 divided by 500 plus 300. That's going to give me 420. I'm just going to type that into the calculator. So what does this mean? This means that if we were producing 500 items, we would expect our average cost to be $4.20 per frame. In part B, they're asking us to find the marginal average cost. Marginal means derivative, so we need to take the derivative of the equation that we just found. So if I were to rewrite that cost equation, I would rewrite this as 60,000 x to the negative 1 plus 300. And then now I'm in a place where I'm going to take the derivative. Now notice my notation here. This is still an average cost, but it's the derivative of the average cost. So it's important to put that bar over the C as well as notate that's a derivative. So we have negative 60,000 x to the negative 2. And then if we were to find that value at 500, we're just going to plug 500 into our equation. And that's negative 0.24. So notice the negative here. Okay, that means our average cost is decreasing when we're producing 500 items. And remember, average cost means cost per frame. So our average cost is decreasing at a rate of 24 cents when our production level is 500. And it's important to note that production level here because this value would be different at different production levels because it's based on an equation. And notice that that's not in a linear equation, so it's not a constant rate of change there. And then C. C is asking us to use the results from parts A and B to estimate the average cost per frame if 501 frames are produced. So what would be that cost? So what would be the cost of the 501st frame? So in part A, we found that value to be 420. And we are decreasing that cost at a rate of 24 cents per frame. So if we were just to subtract those two values, that tells me my cost.